to Checkmate Scholars. In today's video, we're going to be going over the 5th grade science STAAR test from 2025. But before we actually do that, we're going to do a brief review over some high yield topics that you need to know before you go into your STAAR test. If you're new here, make sure to subscribe and comment and like. And also, don't forget to check out the links in the description. There you're going to find the 1 hour of free tutoring that we offer to new Checkmate Scholars members. And you're also going to find the link to the TEA website where you'll be able to find more practice tests that you can use to prepare for the STAAR test. All right, let's get started. So as I mentioned before we do the practice test and we do a couple of practice questions, we're going to do a brief review. And the purpose of this review is just to know the high yield topics, the topics that are likely going to come out the most in the STAAR test. These are concepts you must know. All right, so first we're going to be looking at density. It's one of the properties of matter, right? What is matter? Matter is anything that has mass and takes up space, right? Mass is, by simple definition, just that weight, right, that the matter has, right? So this piece of matter, this cube, has more mass, right, than this one. This one is a bit more hollow and it's filled with a bit more air, right? And then within the air, you see all these small circles, right? These small circles, we can count them as mass, right? So it's the weight that this block holds, right? In simple terms, this block has a little bit of mass compared to this block, which has a whole lot of mass, right? And so what does that mean when it comes to the term density? Density is the amount of mass packed into a space, right? So here we have two blocks. They're the exact same size, right? But this block on the right side, under the term high density, has a lot more mass. It has a lot more mass. It's more stuffed. It's more full compared to this block right here under the term low density. And so density, again, is the amount of mass within a space. So if something is more full, right, it's going to be more dense. Okay. If it's less full, it's going to be less dense. Okay. Now, what does that mean when it comes to water? We're actually going to see that shortly. So here we have mixtures and solutions, which we'll dive into. But first, I want us to look at this picture right here. It's a cup of water with some marbles in it. These marbles sink to the bottom. Why? Well, they're more dense than the water. Okay, so whenever something sinks in water, it's more dense than the water. So if we look at this illustration, let's say we put both of these blocks inside this water. Which one is likely to sink? It's going to be this block right here. This block is going to be likely to sink. Why? Because it's more dense, it's more full, it has more mass inside it, right? So it's probably going to sink all the way down. But if we look at this block right here, it's less dense, right? There's less mass inside of it. And so because of that, it's probably going to stay on the surface. It's probably going to be less dense than the water, okay? So remember this. This is a key concept to remember. Density is going to be the amount of mass within a space, okay? And if something is able to sink in water, that means that it is more dense than the water. If it floats, kind of like these bubbles right here, then that means it is less dense than the water. So if it sinks, it's more dense. If it floats, it's less dense. All right, next we're going to be moving on to the topic of mixtures and solutions. What's the difference? So a mixture is when you combine two things, okay? You combine them and you can distinguish the two or more things that you put inside. So here we have marbles and we have water, right? And so the marbles, right, that's the component of the mixture, and the water is also a component of the mixture. So we can distinguish the two things. We can tell them apart. Here we have the water and here we have the marbles, right? And it doesn't have to just be two things. It can be 3, 4, 5, 10, 100 things. Consider something like maybe a salad, right? You have your lettuce, tomatoes, cucumbers. Some people put chicken in their salad. That's a mixture because you have more than one thing being combined physically, but you can still tell them apart. If I gave you enough time, you could probably separate a salad into a pile of lettuce, a pile of tomatoes, a pile of cucumbers, and even a pile of chicken. And so you can separate the pieces of that salad. So that's why it's considered a mixture. But a solution is a bit different. A solution, yeah, you're combining things, but you're combining things that are going to dissolve, okay? So here we have salt and water, okay? So the salt is going to dissolve in the water, and you won't be able to tell it apart, right? So if we look at this right now, it kind of looks the same. This salt water kind of looks the same as this regular water. The only difference is that there's salt particles. There are salt particles mixed into the water particles. And so basically we can't tell it apart. So this is a solution. A solution is where you have one thing dissolving inside another thing. The technical term, if you're taking notes, is going to be solute and solvent. Okay? Solute and solvent. Your solute is the salt. It's going to dissolve in the other thing. This is the medium. This is the solvent. Okay? So the solute is the salt. The water is the solvent. So let's say I wanted to make Kool-Aid. I have the Kool-Aid powder and I have the water. What would be the solute and what would be the solvent? The solute would be the Kool-Aid powder because that is going to be poured inside the water and it's going to be mixed in the water. What would be the solvent? The solvent would be the water. Let's try another example. Let's say I wanted to make hot cocoa. I have some milk and I have some cocoa powder or some chocolate powder. Which one is the solute? Which one is the solvent? The solute is going to be the cocoa powder. The solvent is going to be the milk. So I hope you see how that works. All right, let's move on to the next concept. Here we're going to be looking at changing states of matter. All right, this is another very important topic that you must know. What are the three types of matter? We have solids, liquids, and gases. All right, your solid is going to be anything that's hard and tangible, kind of like your laptop, the phone maybe that you're watching this on, a pencil, a notebook. Liquids, your water, right? Juice, milk, all those are liquids. Gas, think about steam, think about carbon dioxide, think about helium or oxygen. Those are gases. Now, how do these states of matter change? Well, let's start with solid. If we're going from solid to liquid, I always like to think about water. Okay, water has three states of matter, right? So solid water would be what? That would be ice. Okay, so when I want to turn ice into water, what do? I melt it. Okay, I melt it. So if you put a block of ice inside the microwave, what's going to happen? It's going to melt. It's going to turn into water. Now, if I put water in the freezer, what's going to happen? It's going to freeze into ice. Okay, so these two, very basic, you must know them. What about condensation and evaporation? Well, liquid, when it turns into gas, that's called evaporation. So if I put some water on a stove, okay, on a stovetop, or I put it in a pot and I turn the heat on, the water is eventually going to transition into gas. Okay, so that's going to be the steam you see above a pot. So the transition in state from liquid to gas is evaporation. What about from gas to liquid? This one isn't so popular. It's not as popular as the other ones, but it's equally as important. It's called condensation. Gas turning into liquid is called condensation. What does that mean? That's basically when the gas cools down enough to become a liquid. Okay, so these blue arrows, as you can see, these are all going to be moments in which you have colder temperatures that are causing the change. The red arrows are the warmer temperatures. Okay, so gas turning into liquid is called condensation. So the gas is cooling down to a liquid. Now, there are two popular examples of condensation that we see from time to time. The first example is going to be when you have a soda can. If you ever bring a soda can out of the freezer, or out of the fridge, I should say, and you place it on the table in room temperature, what's going to happen? You're going to start to see all these little bubbles. That is called condensation. Okay. What now? Remember, we said condensation is when air or gas gets cold and turns into a liquid. Well, what's happening here is that the air molecules, right? The air molecules are cooling down, turning into these small water droplets, and millions of these air particles are cooling down into these millions of water droplets. Okay, so this is one example of condensation. It's cooling down. Why? Because it's touching this cold can. So whenever you touch a can of soda, right, a cold can of soda, you feel it in your hands. It's cold. In the same way, the air around this can is coming in contact with this cold can, and it's cooling down to form these small water droplets. The other example we can look at is here. Whenever you have the water cycle, which we're going to go in a bit of detail soon, right? You have the water that evaporates, and then once it gets all the way to the top in the sky, it starts to cool down. Okay, so imagine the sun is shining its rays downwards, right? But once the water gets to the sky, it condenses, it cools down, and it forms these clouds, right? And these clouds are basically a huge collection of water droplets. Okay, so we're going to get to that shortly. So that is condensation. Remember, condensation is just a cooling down of a gas to a liquid. Now let's go from gas to solid. What are the two types of changing in matter? These ones are a bit less popular, but also good to know. You have deposition and sublimation. Okay, deposition is going from gas to solid. Sublimation is going from solid to gas. But the main ones I want you to know for your 5th grade STAAR is going to be freezing, melting, condensation, and evaporation. These 4 are crucial. Make sure you know them. All right. Next, we're going to be looking at energy transformation. All right. So what is energy transformation? Energy transformation is when energy, one form of energy, transforms to another form of energy. So I want you to picture this in your mind. You have a toaster, right? Maybe you're in your house and you have a toaster. How does that toaster work? Okay, if you plug the toaster into the wall socket, right, it gets electricity from that socket. Well, what does the toaster do? It heats up bread or bagels or pancakes. It heats it up, right? And so basically, that's a transformation in energy. As you plug in the toaster, the electricity comes from the socket, and the toaster transforms that energy into heat energy to heat up the bagel you're toasting, the Pop-Tart you're toasting, the bread you're toasting. So when you plug in a toaster, you have a transformation of electric energy to heat energy. Okay? What about solar panels? Well, a solar panel, right, is going to get light energy from the sun, and it's going to turn that into electric energy. Okay? What about a speaker? Think about it. What about a speaker? A speaker is going to take electric energy, right? And it's going to use that to amplify or create sound energy. Now, what about this man right here? He's riding a bicycle, and it's turning some gears, and it's causing this light to form in the light bulb. What is the transformation of energy here? If you know, drop it in the comments. Hey everyone, if you're interested in a free 1-hour tutoring session with Checkmate Scholars, make sure to click the link in the description. That link will send you to a Google document where you can sign up for your student. All right, let's get back to the video. Next, we're going to be looking at insulators and conductors. This is another important concept that you should know for your STAAR test. So what is a conductor? A conductor is something that allows energy to pass through. Okay. What is an insulator? An insulator is something that stops or slows down energy. So Anything that allows energy to pass through is considered a conductor. So we have a lot of metal items here. Typically, metal items conduct electricity. That's why a lot of your electronics, if you notice, a lot of them have a lot of metals inside, right? Not just on the outside, but on the inside. If you look at the charger you use to charge your phone, the tip of that charger that goes into your phone or into the socket is what? It's a metal. So these are conductors, okay? Now what about insulators? They stop or slow down energy. So we have wood, cotton, plastic, rubber, porcelain. These are all different types of insulators. So if you notice on your charger, right, you look at most of that charger, you'll see that most of it is coated in some type of substance. For some chargers, it's typically a rubber substance, okay, or a plastic or rubber type of substance that coats the charger. So that way, whenever you're touching the charger, you don't get shocked, right? But when you plug it in, the metal portion is what conducts the electricity to your phone, okay? Let's keep on going. Now let's look at how light travels, okay? Now light is very unique, okay? Typically light travels from a light source to your eye. But how do you see objects? Typically light travels in these little particles. They hit the object and they reflect off of the object to your eye, okay? So you can kind of think of light particles as these little scoopers, right? They scoop up the image and they bring that image to your eye, okay? So what's happening here is basically a reflection. Basically where light comes from a light source, it bounces off and reflects off of this object and comes to your eye, okay? So that's how we're able to see everything around us, okay? That's how you're able to see this YouTube video. That's how you're able to see a car or the birds in the sky. Simply because light comes from the light source. Sometimes this light source could be the light in your room or the sun or a flashlight, or in this case, a candle. The light comes in little particles. It scoops up the image and brings it to your eye. Now, the term I want you to remember is called reflection, okay? So basically what's going on is that the light is coming, it hits the object, bounces off, and reflects into your eye. So just as we have a mirror here that's reflecting light, the same phenomenon is happening with this apple. I don't know why it's red and green, but you get the point. Light comes from the light source, bounces off or reflects off the object, and hits your eye. That's how you're able to see. Now there's another R word that I want you to remember. It's called refraction. What is refraction? Refraction is when light bends, okay? Light bends, okay? It's the bending of light as it moves through a different medium or substance. So in this case, you have your light, it's coming through the air, but it hits the water, so it bends. So that's why sometimes if you put a pencil, but not sometimes, but all the time, if you put a pencil in water and look at it from the side, it looks like it's bent a little bit. So that's refraction. So light passes through and bends. But reflection, light bounces off the object and goes another direction, typically towards your eye. All right, now we're going to look at another concept. This is the Earth's rotation. This is another concept that you must know, okay? What does Earth's rotation cause? It causes day and night, all right? So we're probably right here. This is a weird drawing of North and South America, but we're probably right here. So anytime Texas comes around and is in contact with the sun, that's day. But once this part of the world goes around and ends up on here, on this side, this is night because it is not facing the sun. What causes night and day? The Earth's rotation. Always remember that. Rotation. Rotation. Say it with me. Rotation. Now there's another R word. Wow, we've had quite a number of R words. We've had reflection, we've had refraction, we have rotation, and we have one more. Hopefully, this is the last one. Hopefully, we have revolution. What is a revolution? A revolution is where the Earth travels around the sun. Okay? So this is different from rotation. Rotation, the Earth is spinning around its axis, kind of like you spin a top. Or for those of you that know Beyblade, or kind of like a Beyblade for the guys out there that like to watch Beyblade, or maybe for the ladies, a ballerina spinning on her toe, right? So that's rotation. Revolution is where the Earth travels around the sun. Now, what does this cause? This causes our 4 seasons: summer, autumn, winter, and spring. This causes our 4 seasons. So if I were to ask you what causes night and day, you would say rotation. What causes what causes our 4 seasons? You would say revolution, right? So that's the difference. Now we're going to look at the water cycle. We previously looked at this for the sake of understanding condensation, but I want us to look at it one more time. So your water cycle is always going to start here in this area. You have your water all around the place, and the sun's rays are going to hit the water, and it's going to cause the water to heat up so much that it changes matter. All right, so we're going from liquid to gas. We're evaporating. But once it reaches the sky, up here it's kind of colder than down here. So what's happening? The water vapor, the steam, is going to cool down and form these clouds. Clouds are basically just a huge combination, or a huge collection of water droplets. That's why when it's foggy outside sometimes, and basically what is fog? Fog is the phenomenon where these clouds come to the ground. And that's why when it's foggy and you're walking through fog, it almost kind of feels wet outside, even though it's not raining. So that's how you know that these clouds are just a collection of water droplets. So we're starting here at liquid. The sun heats it up, turns into gas, evaporates, right? And then it condenses, it cools down and forms these clouds, which is a collection of water droplets. After a while, it rains. So after we get enough water droplets in these clouds, it's gonna rain. That's called precipitation, okay? Precipitation. And then it starts all over again. The water flows down, your mountains, your hills, flows down some of these trees, collects in a river, and then into these large bodies of water. All right, let's move on. Now we're going to move on to rocks and fossil fuels. Specifically, I want you to remember one rock in particular: sedimentary rocks. What are sedimentary rocks? These are rocks formed by sediment. Well, Isaac, what is sediment? Sediment is going to be your mud, sand, dirt, all this stuff on the ground, okay? Sediment. Over time, you're going to have a lot of rocks and a lot of dirt, mud, and sand, and it's all going to compact. And that's why you see these layers. These are all just layers of dirt, mud, and sand that have layered up over time. This rock is probably taken from somewhere like this, where you have different layers. And so this is a sedimentary rock. And in each and every one of these layers is a different layer of maybe sand, mud, dirt. You have different layers, okay? So that's your sedimentary rock. And this is actually where your fossils are found, okay? So in sedimentary rock, you have a lot of fossils. Why? Well, what are fossils? Fossils, by definition, are basically the remains of these ancient organisms, right? These are ancient organisms that died, and when they died, basically they fell flat on the surface of the ground, right? And as time progressed, you had wind bring in a lot of sand, you have different types of dirt cover it, and a lot of the sand, dirt, mud, and different things that created these layers are going to layer up on top of these organisms. And so that's why whenever you find fossils, they're typically found in rocks, in these sedimentary rocks, because over time, let's say they died on this surface right here. Over time, you're gonna have a lot of mud, a lot of sand, a lot of dirt compacted, and it's gonna eventually form a fossil. And so that's why you have all these different types of fossils. That's where we find dinosaur bones and the bones of some aquatic ancient organisms. Now, with your fossils, you get fossil fuels. What are fossil fuels? Fossil fuels are basically the fuels that are formed from the remains of these ancient animals. So all these ancient animals right here, with time, there's going to be so much pressure, right? So much pressure. You can imagine how much pressure is down here. The weight of this whole canyon, this whole mountain is pressing down on whatever is in this layer right here. And that's going to cause these organisms to decay. And it's going to get us our three types of fossil fuels. You have your natural gas, your oil, and your coal. Okay? These are your three types of fossil fuels. Now, these are not the good types of energy. Okay? Your fossil fuels, they make energy, but they are non-renewable. What does that mean? That means that you can't make them again. Once it's used up, it's gone, right? It's gonna take a very, very, very long time to get another one. Why? Because once we used up all the fossils and the fossil fuels from, let's say, 1,000,000 years ago, we can't just get a new fresh batch today. The animals that die today are gonna have to go through a whole process like this where they are compacted until they get all the way right here, maybe around here, and that's gonna take millions and millions of years. So it's non-renewable. It takes up too much time. But you have renewable energy that can be renewed. It can be found again. It can be easily restored again, right? So you have solar energy. Do we have to wait for the sun? No, we don't have to wait millions of years for the sun. Once it's daytime, your solar panel can collect light energy from the sun and transform it into electric energy. What about wind energy? Sometimes you see these wind turbines, right? They harness the power of the wind. The wind is always gonna blow, right? You have your hydropower energy, your energy from, let's say, your flowing rivers that turn some turbines. So these are just a couple examples of renewable energy. So renewable energy is good. Non-renewable energy is not so good, right? This energy, once it's used up, it's gone. But renewable energy is always going to be available. All right, now we're moving into the last portion of our review, which is going to be understanding the different types of environments, or some people call them biomes or ecosystems. The first one we're going to be looking at is the prairie. So the prairie is going to be a grassland, okay? So it's just a large expanse of land covered in grass. So you see grass all over the place. This is what is called a prairie, okay? Next, we're going to be looking at a desert. This one is pretty popular. We all know this is a desert. It's very hot. It's very dry. Compared to a prairie experiences more rain. It experiences more rain. It's not as hot, but a desert has less rain. It's way hotter. You have less vegetation. So you see there's little patches of grass, but there's way more sand and rocks and gravel because plants can't grow here. It's too hot. Now we're looking at the forest. This is pretty well known. It rains quite a lot. You can see some leftover water, maybe from a rainstorm. You have a lot of trees. That's one good character about rainforest. There's a lot of greenery, a lot of trees. This is the tundra. The tundra is going to be cold. It's not super duper cold, but it's going to be really cold. And it's characterized by mainly just the land and vegetation. There's not a lot of trees. It's a treeless, almost a treeless environment. It's cold. It rains a little bit, not always, but it's pretty cold and treeless. Lastly, we have the Arctic. This is the most extreme cold environment on the globe, okay? You have your polar bear right here, but it's just really cold. Only animals that have a lot of fur and insulation can stay in the Arctic environment. All right, let's take a look at a couple of questions. Question number 1 says, this drawing shows fossils in different layers of soil. So we have the top layer, layer 1, layer 2, layer 3, layer 4. Layer 4 is at the bottom. Based on the fossils, which statement best describes one of the layers? All right, let's look at layer 1. Layer 1 was a desert. Okay, so this question is basically analyzing what we know about deserts, Arctic tundras, and other biomes and ecosystems, and what we understand by these fossils. Now, how do we know layer 1 was or wasn't a desert? Well, what's in a desert? A desert is a dry place, not a lot of vegetation or greenery. You have animals that can survive in the heat. Let's look at layer 1. Well, we see 2 leaves, which is pretty rare for a desert, right? A desert is going to be a hot place without leaves or without vegetation. Typically going to have maybe a cactus or maybe dry branches. And I don't know what this animal is, so let's leave out number 1. Let's check number 2. Layer 2 was an Arctic tundra. Well, what's an Arctic tundra? Well, we have two words. We have Arctic, which represents a really cold area. And we have a tundra, which represents a treeless area. It's pretty cold, but not so cold, right? So an Arctic tundra. Let's see. So here we have an animal that kind of looks like a frog. It has frog legs. We have a dragonfly. We have this thing that looks like a leaf of some type of tree. Could this be an Arctic tundra? I don't think so. Well, this is a dragonfly, right? This is a frog, and they don't live in Arctic environments. Same with this tree leaf, or this branch, or whatever it is, some type of vegetation or greenery. This can't be in an Arctic tundra because these things don't typically survive in Arctic environments. So B is also wrong. Let's check out layer 3. Layer 3 was an ocean. Let's look. We have a crab and we have a seashell. Now, a crab is an oceanic organism, and the same with this shell. This would typically be found near an ocean. So layer 3 could possibly be from an ocean environment. So I like C. Let's keep C. Layer 4 was a forest. What do we have here? We have a fish carcass, we have another fish carcass, and we have another seashell. These would typically be found where? In an ocean, not a forest. So D is incorrect, so we're going with C for question number 1. Let's check out question number 2. Students place a toy elephant on the floor in a room without windows. The students turn the room's light on and off and record their observations in the table. So when the light is on, they can see the toy. When the light is off, they can't see the toy. Which statement describes the conditions that allow the students to see the toy? Okay, well, what do we know about light and seeing stuff? We know that light has to travel from a light source. It travels to an object and it bounces off that object, or it reflects off the object and goes to our eyes. Which statement best describes, or which statement describes the conditions that allow the students to see the toy? Light rays reflect off the toy and travel to the light bulb. Well, yeah, the light rays reflect off the toy, but do they travel to the light bulb? No. They travel from the light bulb, but they travel to our eyes. So answer choice A is incorrect. Let's check out answer choice B. Light rays reflect off the toy and travel to the student's eyes. I like answer choice B. It reminds us of our illustration in our review. Light rays reflect off the toy. That sounds correct. Let's check out answer choice C. Light rays reflect off the toy and travel to the light bulb? Again, the light rays aren't traveling to the light bulb, they're traveling from it. The light bulb is the source, so the light is traveling away from the light bulb. So answer choice C is incorrect. Let's check out D. Light rays refract off the toy and travel to the student's eyes. Yeah, the light rays travel to the student's eyes, but they don't refract off the toy. Remember, refraction is when light passes through. In order for light to hit an object and get to our eyes, it has to reflect. So answer choice D is incorrect. So I meant to say refract here in answer choice C. So answer choices A, C, and D are incorrect. So we're going with answer choice B. Number 3. It says the life cycles of 3 organisms are shown. Which statements about the life cycles are correct? Select 2 correct answers. Alright, we have a mosquito life cycle, a tomato plant life cycle, and a ladybug life cycle. Let's look. The tomato plant should have a pupa stage. Well, what is a pupa stage? We didn't go over this in the review, but this is something that you can definitely write down. A pupa stage is kind of like a transition in between the larva stage, okay? In between the larva stage and the adult stage. So the pupa stage would be somewhere like right here. The pupa stage is a transition, okay? It's where an organism, something like an insect or a bug, is transitioning from a little kid to an adult, okay? A tomato isn't an insect. It doesn't really represent the life cycle of an insect. Pupa stage is typically reserved for our insects, okay? Not plants. So A is wrong. Let's check out B. Part of the mosquito life cycle occurs in water. Let's look. Our mosquito life cycle is right here, and as we can see, the life cycle does occur in the water, so I think B is a good choice. In all the life cycles, the young organisms look like the adult organisms. That is not true. We have our larvae here, we have the egg here. This larvae looks nothing like the adult. Same with the seedling, it looks nothing like the tomato. Same here with the larvae and the pupa, they look nothing like the adult. So this is incorrect. Let's check out D. The seed of the tomato plant is like the egg of the ladybug and the mosquito. Well, that sounds pretty accurate. If we look here, the seed of the tomato plant being the same as the egg of the mosquito and the ladybug, that sounds accurate. Why? Because this is where it starts. This is the starting point. This is where the mosquito starts and travels and becomes a mosquito. The seed, this is where the tomato plant also starts. It transforms into a tomato, and the same with the ladybug egg. It starts here and transforms into the ladybug. So I like the D answer choice. Let's check out E. An adult is not needed in the plant life cycle because plants come from seeds. Well, how does this necessarily work? If an adult isn't needed, right, and plants come from seeds, well, where do the seeds come from? The seeds come from the plants, and the plants are the adults, right? So to say we don't need the adult is to say that we won't be wanting any seeds, because the plant, right, the plant gives us the fruit that houses the seed. Remember, if you cut a tomato open, you're going to see a lot of seeds inside. So yeah, we need the plant, but the plant gives us the fruit, which is the adult, right? And this is where the seed comes from. So I don't like answer choice E. The best 2 we have are B and D. A teacher places a lamp on a small table. After the lamp is turned on, an office chair is moved near the table. The diagram shows the setup. How could a student help the teacher demonstrate the day-night cycle of Earth? This is a good question. Now remember, how does day and night occur on Earth? Remember the R word, rotation. In order for the light right here, which in this case is symbolizing the sun, in order for that to cause day and night on the Earth, which is being symbolized by this chair, the Earth has to rotate. It has to rotate. So we need to look for something that causes the chair to spin or rotate. Let's look at our answer choices. All right, A says the student could sit in the chair and make the chair move around the table. Well, what R word does that describe? That doesn't describe rotation, that describes revolution. Revolution, remember, means to go around the sun. But that causes what? That causes our 4 seasons. That doesn't cause day and night. So answer choice A is incorrect. Let's try B. The student could sit in the chair and cause the chair to make one complete spin. That sounds like a good answer. Why? If the student sits in the chair and spins around in the chair, right, that symbolizes or represents rotation. Remember, rotation causes day and night. So I like answer choice B. Let's check out C. The student could sit in the chair and then the teacher could move the lamp around the chair. Well, that's not really accurate. Remember, the sun doesn't move, it's the earth that moves. So C is not a good answer. The student could sit in the chair and the teacher could walk between the student and the table. Again, that doesn't cause day and night. What causes day and night is the rotation of the earth. All right, so the best answer choice here would be answer choice B. It says adaptations of 3 animals are shown in the table. So we have a fennec fox, a badger, and a hare. Let's look at the adaptations. So a fennec fox has large ears for cooling, light color fur for camouflage. A badger has sharp claws to dig burrows, and it flattens body to get through soil, okay? And a hare has thick fur and small body to save heat. Based on the table, in which environment is each animal most likely found? All right, so we're gonna move these into the environment here. All right, so let's start off with the fennec fox. It has large ears for cooling. So let's actually pause there. Large ears for cooling. If you're cooling down, are you going to be in a hot or cold place? You're likely going to be in a hotter place, right? A fennec fox probably won't be maybe in the Arctic or the wetlands or even the ocean, right? These areas aren't really hot. They're cooler places, especially the Arctic. So we're left with the desert and prairie. Let's keep looking. Light color fur for camouflage. Well, if it has light color fur, let's say like tan colored or cream colored, is it gonna camouflage better in the desert or the prairie? I say the desert. Why do I say the desert? Because the prairie is a grassland. There's a lot of greenery, a lot of grass. It's just a lot of grass in general. But a desert is more tan/cream colored, right? It's probably gonna be a lighter color, better for camouflage for the fennec fox. So the lighter color for camouflage will probably fit best for the desert. Also, it's a place that needs cooling, right? The desert is so hot, and so a fennec fox that stays in the desert would benefit from having large ears for cooling. Let's look at the badger. The badger has sharp claws to dig burrows. Let's see. It flattens its body to get through soil. Well, where do we find soil? We don't find soil in the Arctic or in the ocean. We can find soil in the prairie or wetlands. All right, let's see. We're digging burrows. Can you dig a burrow in a wetland? Probably not. If there's a lot of water, a lot of moisture, right? You're not digging through soil, you're digging through mud. And if you try to dig through mud to make a burrow, you're gonna have a really tough time. So the badger most likely stays in the prairie, right? You have a lot of soil there. Let's look at the hare. It has thick fur and a small body to save heat. Where would that be needed? Do we need thick fur in the Arctic, ocean, or wetlands? You probably need thick fur in the Arctic, right? The ocean isn't a place where a hare would stay. Wetlands, maybe, but I think you would need thick fur definitely in the Arctic region, right? Because it's so cold and you need to save heat, right? Both of these adaptations refer to saving heat. Thick fur, right, to stay warm, and a small body to save heat. So that's probably going to be in the Arctic. So these are our best answers for where these animals are most likely found. So before we end, I did want to end on question 5, but question 7 is a very good question that also relates to the density concept that we covered in our review. And I think this is something that we should definitely practice. So let's take a look at it. A student drops 5 objects into a container. So we have 1, 2, 3, 4, and 5. Which statement best classifies some of these objects? Now remember, see, all of our answers are related to density. Remember, density is how much mass is packed into a space. If something is more dense, that means it's heavier. If something is less dense, that means it's lighter. So keep that in mind. And remember, in relation to water, if something sinks, it is more dense than water. If something floats, it is less dense than water. So let's take a look at our answer choices. Objects 2 and 5 are more dense than water, while objects 1 and 4 are less dense than water. 2 and 5. 5 doesn't sink. It kind of just stays in the middle. And this is a concept that we also need to go over that we didn't quite cover in the review. But if something stays in the middle like this, it isn't more dense than water. All right? It's the same density as water. Okay? Keep that in mind. It's closer to the same density as the water. Okay? So part of this is true. Objects 1 and 4 are less dense, but object 5 is not more dense than water. If it was more dense, it would be all the way at the bottom. Okay? Objects 1 and 4 are more dense than the water. That's not true. I don't even need to read the rest of this answer choice. Objects 1 and 4 are less dense, not more dense, because they're floating. Objects 2 and 3 are less dense than water. That's not true. If something is less dense, it's gonna float. If it's more dense, it's gonna sink to the bottom. Objects 1 and 4 are less dense than water, okay? While object 2 is more dense than water. Yep, that's true. Objects 1 and 4 are less dense because they float. Object 2 is more dense because it sinks. So that's correct. Alright everyone, that brings us to the end of today's video. If you found it useful, I'd really appreciate if you could give this video a like. Also, maybe share it to a student that could maybe benefit from this type of content. Remember, in the future, we are going to other grade levels for STAAR test prep, so make sure to subscribe so you're updated when we do release those videos. Also, if you'd like one-on-one tutoring for your student, don't forget to check the link in the description. There you can access the sign-up link for Checkmate Scholars. Remember, for new Checkmate Scholars customers, you do get 1 hour of free tutoring, so don't let that opportunity pass you by. Sign up today. As always, I'll see you in the next video. Until then, checkmate.